Hello students, welcome back. In this part of my video, we will be moving on to the second example for relative measure of dispersion. Okay, so compute relative measure of dispersion on the following data. Now this is the data. As you can see, it's an group data. It's a group data, or you can say it's a case 3 data, which we in which class intervals are given, and for every class interval there is corresponding frequency written next to it. Okay, so the class intervals are 2.5 to 2.9 having frequency 2, 3 to 3.4 having frequency 7, 3.5 to 3.9 having frequency 17, 4 to 4.4 having frequency 25, 4.5 to 4.9 having frequency 20, 5 to 5.4 having frequency 12. Now this is basically the range of this class, which is 5 to 5.4, 5.5 to 5.9 frequency 9, and 6 to 6.4 the frequency is 8. If you add all those frequency, you get a total of 100. We need to prove relative measure of dispersion on the following data. Now whatever measures we will be proving, whether it is range, coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, and coefficient of variation, we need to keep this thing in mind that the calculations, if all the calculations done out here are done the way all these parameters are done. Okay, so in order to find relative measure of dispersion, we need to find out all the parameters which are median, quartiles, and standard deviation, and all those measures are calculated in terms of group data. So let's get started. Okay, so the first is coefficient of range. As you know, the formula for coefficient of range is equals to maximum value minus minimum value divided by maximum plus minimum value multiplied by 100. Alright, so the first thing is xm minus xn divided by xm plus xn. We need to find out the maximum value, which is 6.4. The minimum value is 2.4. If just go back to the data, I've already explained it in my previous video that how to find out range of a group frequency distribution. So you're going to look for the last interval, upper interval of last class minus lower interval of first class. Okay, so this is the minimum value, and this out here is the maximum value of the group frequency distribution. Okay, so next step is that we're going to substitute these values into the formula. 6.4 minus 2.5 divided by 6.4 plus 2.5 multiplied by 100, which is equals to 0.4382 multiplied by 100, and it gives me the answer of coefficient of range is 43.820%. Moving on, we now be doing about coefficient of quartile deviation. Now the formula for coefficient of quartile deviation is Q3 minus Q1 divided by Q3 plus Q1 multiplied by 100. Okay, so Qi is equals to L plus H upon F into I times summation F by 4 minus Cf. Now as you know that we are solving quartiles for a group frequency distribution, so we're going to use the formula of group frequency distribution to find out values for quartile. Now we need to find out quartile 1 and third quartile, which is lower and upper quartile. So we're going to substitute 1 in this position of I to find out value for first quartile. Okay, and I'm going to substitute 3 into this position, alright, to find out value for third quartile. So 3 will be here, so like 3 times summation F by 4 and 1 times summation F by 4. Okay, so I've already calculated the values of quartile. Now you can calculate it on your own and verify your answers. Okay, that how these values came. You just use all the steps that are required to find out quartile values. So I have calculated quartile values, which is equals to 5.12, which is my upper quartile value, and my lower quartile, which is Q1, is equals to 3.92. The next step is that I'm going to substitute my quartile's value into this formula. So coefficient of quartile deviation is equals to 5.12 minus 3.92 divided by 5.12 plus 3.92 multiplied by 100. Alright, so coefficient of quartile deviation is equals to 0.1327 multiplied by 100. Alright, so coefficient of quartile deviation is equals to 13.274%. This is my final answer. Coefficient of quartile deviation, which is 13.274. Moving on for coefficient of mean deviation. So for about mean, the formula is coefficient of mean deviation is equals to mean deviation about mean divided by mean multiplied by 100. So for mean deviation, we're going to use the formula which is summation f into absolute x minus x mean divided by summation f. As you know that this is the formula for group frequency distribution. So we're going to use that and find out our answer. Since mean I've already calculated, which is equals to 4.53, you can verify your answers by calculating mean, which is the formula is summation fx divided by sum of f. Okay, so coefficient of mean deviation about mean. Now out here I've also calculated value for mean deviation about mean, which is equals to 0.7066. Okay, so you can verify your answer, or you can check your answers by using the formula which I have told you earlier, which is here. Okay, use this formula and you'll find out the value. You can use this formula and you can find out the value for mean deviation about mean. So 0.7066 divided by 4.53 multiplied by 100. Okay, solving it gives me 15.598%. So my coefficient of mean deviation is equals to 15.598. Alright, so about median. Coefficient of mean deviation about mean is equals to mean deviation about median divided by median multiplied by 100. So the formula for finding mean deviation about median is equals to summation f absolute x minus x median divided by sum of f. Now median value is calculated as 4.43. Now since it is a group distribution, frequency distribution, we'll use the formula of group distribution to find out value, and after using that formula you can just you can go through the calculation and you can check it or verify yourself. Alright, so mean deviation about median. So I've given the answer that how mean deviation about median, which is calculated as 0.7046. Now I've got my median answer, I've got my mean deviation about median answer. The next step is to substitute these two values into the data so that I can get my final answer. Okay, so coefficient of mean deviation about median is equals to mean deviation about median divided by median multiply by 100. Alright, so which is equals to 0.7046 divided by 4.43 multiply by 100 gives me an answer of 0.1590 multiply by 100. So my final answer, coefficient of mean deviation, is about median, which is equals to 15.905%. Alright, so we're moving on towards the last coefficient, which is coefficient of variation. As you know, the formula is sigma upon mean multiplied by 100. Sigma is summation fx squared divided by sum of f minus summation fx upon sum of f whole square. Now I've used computational form here. You can also use the definitional form, the other formula. It is completely up to you. Okay. So I have done a few calculations out here. You can, as I repeat, you can verify it by yourself by following each and every step, and you can came across after solving all the values, you can find out that these were the values, these were the final answers, and sigma is equals to 0.86. Okay, so coefficient of variation is equals to sigma upon mean multiplied by 100. So gives us 0.86 divided by 4.53 multiplied by 100. So coefficient of variation is equals to 0.1898 multiplied by 100, and it gives me an answer of 18.984. Now I hope that you have how to calculate all the relative measure of dispersion on group frequency distribution. I hope that you have learned to calculate coefficient of quartile deviation, coefficient of variation. To find out, as I repeat, that to find out values, to use this formula you need to find out the basic values, which is quartiles, range, standard deviation, mean and median, mean deviation about mean deviation about median. So you need to look for the data, that what type of data is given, use the formula according to the data. You have to look that what type of data is given to you, and you have to calculate your parameter according to it. So I hope you have understood it, and now you can easily calculate relative measure of dispersion on group frequency distribution. Thank you.